Okay. Yeah, I was preparing to share. This is our home page for the MPLS Open Design team. And today's agenda that Loa has proposed is as follows. Hopefully you can hear me.
Yeah, we can hear you.
Okay. All right. Loa, do you want to go through it or let me know?
Quickly, we're looking at action item first. It's only me. I think Tarek might have some action items hidden somewhere. You probably should
Yes.
check the agenda next time and add those explicitly every time.
We are keeping a track of action items on a specific page.
Yeah.
There were a couple of them open, and yeah, when time comes to update, I'll mention.
Okay. So the two I have, I actually pushed them out. They are kind of nesting into each other, and I kind of trying to figure out text for both of them. So they probably will be reported the same day, even though it says the 16th and 23rd just now. So I think we can go ahead to. Do you have any? Do you go to that action item page? Do we have any action items that is?
Okay, we had. Let me see. We had a follow-up, you know, to generalize the programmability of reserved bits, you know, inside the FAI. This was a follow-up action item from one of the meetings a couple of weeks ago. The meaning of a bit inside the forwarding action can be standardized, or it can be programmable, or even signaled in the control plane. So this is one open item. It's still open. I know Kiriti started to look at that, but I believe he's on the call today, and I'll give him a chance. Kiriti, this is about the programmability of the actions rather than standardizing them.
Right. Yes. So it says owner Tarek, but if you want, I can take it.
No, the owner. Well, I was supposed to sync up with you. That was the.
Okay. So we should do that. Yeah.
Yeah. I mean, yeah.
Maybe we do it after the call.
Yeah. I can update that. No problem.
Could you give us an ETA?
Sorry, can you come again?
Can you give us an estimated time of arrival? The 2 lines down, one more line down there.
I see it. Yeah. I think I'm committed to sync up this week with Kriti, and then recircle back. I'll update this action item.
Okay. So the estimated time of arrival is next meeting.
Yeah.
Okay. So put
9/16, September 16.
Okay. For some reason. Okay.
You got
the next.
You got the 9/6.
Sorry.
You got finish a link.
Huh? The 9/16. Maybe it understands it as a link because it's double bracketed. Yeah, it's fixed now.
Yeah. Okay.
The next action item was a discussion about the should we extend the Galgash or keep it? I think you have it as an action item still lower?
Yeah, I think what I said about that is that I want to talk to the pseudo-wire, PALS shares before I go ahead and actually call consensus on it. It's close, but it's not done. You can give me
It's the ETA.
yeah, September 23rd.
Okay. And the next one, we're back to Kiriti. We have to define a policy for putting the data in stack versus out the stack. There should be a clear, the way we put it last time I was attending is that we need a clear directive for things that go in stack versus outside the stack or after the end of stack.
Right. Yeah. So I have, I mean, in the draft today, there's a little bit, but I have some thoughts. So one question, if you're canceling next meeting, which I think is going to be decided soon, you know, then 916 is probably not, well, we can put 916. So I would say 923 for this one.
Okay, fine.
Okay. You said some text exists in the draft, or is it in the page, wiki page?
It's in the draft. It's in the draft. I think there might be some in the wiki page, but I will extend the one in the wiki page.
And when you're done, put the pointer here.
Yeah.
Yeah.
So that's an old action item on describing. I moved to action item 4 here. Describe the use cases applicable to the activity of the design team. We have a page for that, wiki page, and I did some cleanup, little cleanup on that page before I came into this meeting. So I can flip to that and talk about it. Use cases. So we have a use cases wiki that we are maintaining. So there are a couple of use cases that we identified. I did add references. There were action item to update the references for certain drafts that are proposing to use MPLS to carry a network slice ID. And then I added those drafts. Some of them are in MPLS and T's working group and Spring as well. I was trying to do some cleanup here in the NSH or SFC based solution. Do we need to do anything? Greg, last time we recorded that. Why do we need an extended header for this? Today we have a solution, RFC 8595, to do SFC with MPLS data plane. It wasn't clear if we concluded that anything is needed. The solution that exists satisfies what we want. There was an action item, but I'm still skeptical if we need to do anything here. So I want to hear more, from the attendees if you want to come. Let me start with Greg. I think, Greg, you had some context on this.
Well, in regard to NSH SFC, so RFC 8300, I agree we don't need to do it because MPLS in that situation used as a transport. If we talk about MPLS-based SFC, it's 8595, if I remember correctly. Then I think that we do have a problem with OEM in a stacking or composite mode. So when the basic elements can be stacked, how to do OEM is for myself and my co-authors of the draft that started discussion on use of GAL. That's an open question, but I think that I would like to continue discussion of general solution because it could be the basis for solving this MPLS-based SFC OEM problem.
Okay, so I think the limitation is doing OEM with SFC in MPLS data plane. Is that what I heard?
Yes, doing SFC MPLS. We can refer it like we refer SR MPLS for segment routing with MPLS data plane. So if we refer to it as SFC MPLS, then yes, doing active OEM in this environment seems to be an open problem.
Okay, so that's just need further discussion, if I understand it correctly.
We had a discussion, and I worked offline with Stuart and Hoop. And we had comments from Sasha. So as I understand, there is not interest on revisiting 5586 and making GAL standardizing use of GAL in non-MPLS TP environments, because 5586, as I understand it now, only defines the use of GAL in MPLS TP environment, and it's the bottom of the stack label. But what's implemented and how these implementations in the field process GAL now, I think that seems to present the problem or create a de facto standard.
Well, I think there's just some fairly specific connotations around GAL. Like you say, it was very specifically designed to say it's providing an alert to an LSR, to an LSR that intercepts the GAL, usually either at the egress LER or where TTL expires. To say very specifically, just below the bottom of the stack, you'll see an ACH.
Yes, that's the case, Matthew. Why we wanted to have this discussion and why we came up with some updates to 5586 specifically for non-MPLS TP environment, because in SFC, like in SFC and SH, when we're doing SFP OEM, we want to avoid sending SFP OEM packets to service functions. That can be done using NSH, but in SFC MPLS, we thought of using some indication within basic unit, so that SFF doesn't send the packet to service function, but rather continues on SFP.
Right. Kind of.
But what I'm saying is, sorry.
Point of view
what
here.
I'm saying is the connotation around GAL isn't. I know we wrote it and it came up with it in the context of MPLS TP, but it's not MPLS TP specific per se. It's just, I mean, you could use it in any other, to me, as long as what you're carrying in the channel works in that environment. You could use it in a, you could potentially use it in unidirectional RSVP LSP, for example. There's no reason in principle why you couldn't do that.
So I think the question is different. If it is not being used in MPLS networks today, then instead of trying to say, oh yeah, we have this mechanism that we can use, and then worrying about how does that interact with FAI and MIAD, let's just, if people are not using it today and they want to, let's design an explicit mechanism for doing that that is consistent with the rest of what we're doing in MIAD today.
Yeah, I mean, I think my concern is that we may end up finding that we have to, that there's certain things about the way GAL works. Like we're going to need some kind of alert mechanism to say there's ancillary data, and then there's going to be some ancillary data. So it's almost very similar to the way GAL works. It's just got to be more generic.
Right, exactly, and fit in with what we have today, or what we're building.
I agree with you both. That's why we decided not to continue discussion on GAL as a non-bottom of the stack label or multiple GALs, and just participate in the discussions of ancillary data, because it's very likely that the use case we have at hand with the SFC MPLS OEM, it would be just one case where this new mechanism can be used.
So I think we're in violent agreement, but just to underline it, what we're saying is that the mechanism that GAL-GASH provides is useful. So we will take that mechanism. We won't use it as is, as defined by the GAL-GASH RFC, but we will incorporate it into the MIAD framework so that it sits well with the rest of what we're building.
Yes, that will be very good outcome, because basically what we can do, overcome limitations of GAL while reusing GAL-GASH mechanism.
Yeah, okay.
So one question.
Just a quick question. Is this being recorded?
Yes, it is. Yeah.
Okay. Go ahead. Sorry, whoever had the question, go ahead.
I had a question about the applicability of GAL-GASH to the things that we're talking about. So the GAL-GASH was for OAM packets, right? So when doing OAM, it wasn't supposed to be carried with user traffic, right? So
yes. Well, okay, to the certain extent, I can point to this work on residence time measurement in MPLS, which is we use to transport PTP control messages through the domain. So in effect, for the MPLS domain, the PTP messages could have been seen as a user traffic. But what we're doing, we are encapsulating them in special ACH channel, and we use the Scratchpad to calculate time spent in nodes that support this functionality in order to provide better clock synchronization.
There's also there's also things that, so it's not just OEM in the sense of monitoring the OSP. There's control, essentially control plane traffic as well. So the linear control, the linear protection packets flow through an ACH channel, I think, and there's also a channel defined for a management control channel. So yeah, I know we said so it's not OEM only. It's just that it's not supposed to be for user plane data, but it could be what's essentially control plane or management plane or
control management plane.
Yeah.
So, guys, wait a minute now. I think what I hear is that there are at least some outstanding questions, or people might need to read up on it. So my suggestion would be that the action item where we started, we close that and say that, okay, we have a wiki page, we are working on it, and then we schedule a design team meeting 1 or 2 or 3 weeks out to discuss this.
Yeah.
And to prepare that, we need people to actually present what we have and propose text.
So one of the things I was kind of stumbled across a bit with thinking about the requirements draft is having a good definition of what ancillary data is, because I think it goes a long way, possibly far beyond what we would normally carry in an ACH channel.
Yeah.
Well, ancillary data
one of the reasons why GACH isn't necessarily what people want to do.
So ancillary data is, a catch-all term for many different kinds of data.
Kirete, I think we kind of are trying to organize, trying to conclude the action item point, and then go ahead in the agenda. And the discussion that you started now actually goes on the last bullet on the agenda.
Actually, I was responding to Matthew, but
I know.
So let me back up to something. To Loa's point, I think we need to come back and say, why do we say that GAL-GACH, when the RFC was written, why did we say it should only be used for OEM or only be used for control channel, not be used for regular data? I think if we define a general mechanism, the fact that you can use that mechanism with user data may or may not be relevant, but to put a blanket statement saying this should not be used with user packets, unless we know why we want to do that, I think in defining this, we can say, let's make it general.
I may be wrong, but I think, packets that carry the GAL are processed in the slow path. They're not processed at line rate. So,
I see. Okay.
So that, I mean, for OEM and for, those functions, but.
Okay, that I think that
so
over time we've seen that changes with advance of hardware support. So what's used to be done in a slow path now can be done in a fast path. In regard to processing OEM packets always in a slow path, we have example of BFD, which is an OEM protocol, and most of regular hardware support provides the hardware support for BFD, whether it's IP encapsulated or it's pseudo-wire encapsulated using ACH.
So Tarek, to your point, and to incorporate what Greg just said, I think what we should do, especially if we are building this to be future-proof, is not to say this should not be used or must not be used for user packets, but instead to say the use of this option may be processed in the slow path, may be processed in the fast path, may have implications on how much time it takes to process a packet, and thus the ingress should be careful when it inserts this option. So it's not like you cannot use, not GalGash, but the new mechanism that's similar to GalGash.
I think
A blanket statement, I think, that says don't use it.
Yeah, I agree with Kiriti. And to add one more point is also that there's gal gas, but there's gal gas itself without gal. So we should distinguish the two cases as well.
So, Tarek, can we move on the agenda now, and then we?
Let me just reiterate the action item and the outcome, and maybe take an ETA quickly. So we have an action item to discuss with the authors of RFC 8596. Greg, you're owning that. It's to close on the need of an extended header in MPLS for MPLS SFC OEM use case.
Okay, acknowledged.
I need a tentative ETA if you have one.
As I mentioned earlier, I talked to Law about next week, so I would not participate in the meeting next week. So let's give me 2 weeks.
Okay, I put 9/23. The outcome that LOAP is proposing is we can add that on a subsequent design meeting. You could report back to the design team on the conclusion. And I added investigate GalGash processing in slow or fast path.
Thank you.
From Kiriti. That's it. I do have one action item from we didn't go over, which is the provide an example of encoding in P4. It was for Huayu. I'm not sure if we still need that action item or if you have an update on Huayu on that.
Yeah, I actually I'm trying to provide some explanation on how we will implement this kind like the parser and and processing hardware. So it's not exactly only for P4, but I try to explain the implication of hardware cost for different type of header encoding styles. So that was ready, and whenever we have time, I can give a brief presentation.
Okay, and can I add you to next week's?
But next week I'm not available.
Oh, I see.
After next week, I cannot attend meeting next week.
Then a week after is you're attending that?
Yeah, that would be fine.
Okay. Okay, so I have you as ready to talk about it.
Yeah.
Is that accurate? Okay. All right, I'll save this and go back to the agenda. Let me go back to the agenda 1 second. Okay, we're back on the agenda, Loa.
Okay.
I think we went. Are we on? We went over 2. Should be on 3 now.
Okay. So Matthew.
Requirement spec. Any update on that? I think Matthew might have left.
Yeah, he told me he had to leave after half an hour, and we actually took too long time. Okay, so let's keep that.
So he has an update. He sent it in the text. It's it's ongoing. And that's a good sign, and that's what I have as an update.
Okay.
Working on it. Okay. Moving on to item number 4, the MEID architecture and framework document. What's the latest on that, Loa?
It's there.
Before we go there, sorry. So did Matthew put his requirements document on the wiki, or is it somewhere else? Whatever. I don't see it on the wiki.
We don't have
You
it.
don't see it.
Yeah, we don't see it. I think we need an action item for Matthew to add it.
Okay, yeah.
After that.
Do that.
Okay, thanks.
All right. I may have got his name wrong. Okay.
No, I.
No, I? Okay, let me go back and check. Oh. Oh, okay. Double T. That was it. Okay. All right. Going back to the agenda. So we are on item number 4.
So the only thing we say about that today, in 3 to 4 weeks, we will have a first posted version of an outline for the document. I think we also should have an action item on Stuart and me to actually add the wiki page.
If you have a document where there's a GitHub account for the working group that we had opened, maybe you can add it there as well, if you want.
Okay, I'm not very friendly with GitHub, so it probably won't happen from me. Maybe Stuart can do it.
Okay, all right. Any other question to Loa on the architecture and framework document? Okay, moving on to the 5th item, thoughts on encapsulating ancillary data. We had some text.
Yep, click on that.
I clicked on that. That's
yeah. Okay. So I'm just going to talk a few minutes about what I've done. I kind of copied and pasted things in here from different places. So there is every time I read through it, I find discrepancies in terminology, but I have a terminology comment at the bottom of the document, and we will look at that later. What I've done is look at what we can do with the file style SPL, and we see that we have 11 flags, and all this is actually in Creator's document. I'm not changing Creator's document, and I just wanted to do an exercise on what happens if we start looking at flags that actually indicates post-stack data. So I'm at the file style SPL on the text, and you can go down a little bit more. Harriet? Hello? Okay. Yeah.
I was muted. I was muted.
Okay. Okay.
So
what I thought about, I have three different variants of data, and they are indicated by same type of flags. So I said that, okay, I don't want to specify anything here what actually is going to into the specifications, but I want to check on the after the boss, or actually post-stack data as Creator calls it today. Then
I said that, okay, if I have 4 or 5 of those, how does the other flags work? And you can go further down. We have a discrepancy in terminology. When I started this, I called the data we have after the stack for auxiliary data. We now slowly moving to calling it post-stack data. We have so I created flags that will indicate post-stack data, in-stack data, and no data, and then I spread it out in one label, and that's under the TLV structure and the flag legend. Going down a little bit more. So then I created what is kind of a strawman IANA registry, where I said that, okay, we have flags, they mean things. First is actually an end-to-end indication, and then there is a hop-by-hop indication, and then there is a no data indication, and a indication of post-stack and in-stack data. So this table is what I use to actually create the TLV structure I'm using for carrying the data after the bottom of stack. You can go down.
Before going down, do you want to leave a space for user-defined? Like some flags may be user-defined rather than standardized.
I particularly don't care about that just now, because I'm only interested in seeing how the data that goes after the bottom of stack bit, how that behaves.
Right. Okay. I mean, I would like to see space carved out for user-defined from this.
Okay, that's fine. So Tarek, the way I think this operates is actually we define a flag, we take the next flag in queue. So if we've done 11 flags, we take flag number 12, and then we put it there, regardless of which type it is. So
yeah,
you see, I got the type number 1 is an end-to-end. Type number 2 is hop-by-hop. Type number 3 is no data. Type number 4 is the S-bit. Type number 5 is which one was the E? In-stack data. And then I haven't done anything to make a structure, because that explodes the field.
Can I say something? I think now we are digging into too much details without carefully think about actual requirement behind it, because now we are giving this flags. Actually, they have a their own semantics, but it's not clear if we actually need it or not.
Wait a minute. I strongly disagree that way with you saying. We're not doing that. I just created an example on how we can encode data after the stack. The rest is just.
I mean, it's clear we need some flags. That's all. But it seems here we are actually trying to give the definition or requirement for those flags. I think it's too early.
I repeat again and again. That's not what I'm doing. I'm just building a scenario where I can take out the and actually come with a proposal on how to do the after the bottom of stack bit data. It says as an example, it's not a definition, it's just building the apparatus I need to do that. So if you look at any data bit, any flag in this registry, it's not a proposed registry. It's just there to make me being able to look at the bottom of stack, data after the bottom of stack. Grete called it post stack data, and that's what I'm looking at. The rest is not the proposal. Okay, can we go on?
Yeah, yeah, okay.
Okay.
All right.
So I've gone through things that we kind of clear we actually need, and then I look at you go down to the last heading you see there, encapsulation of auxiliary data. And what I say, okay, let's see, we can do something we've done in IETF for a long time. We build a TLV structure. I'm not saying that that is the best thing, but I'm saying, okay, here we have one thing that would work. Now we can start tweaking it. So I work with the outer TLV and sub TLVs inside. And the flags I had before, it's a 7, 11, 16, and 18, are the post stack data flags, and that's what I built into TLV structure. The rest is just there for explaining why they ended up where they ended up. Go down. So we have I built a auxiliary. It's a little bit. I call it auxiliary data for the time being, and I actually meant the post stack data. So I built the TLV as it would have looked if we'd done it the way I prepared it. And now we have a outer TLV and a couple of sub TLVs. The length are the combined length of the sub TLVs, and each of the TLVs has have a length. Okay. Yeah, you can go down. I got comments. Some of them is fairly easy to discuss. Others is kind of surprising to me. So I got one comment from Kireti. It's in the wrong place in the wiki. And yes, I agree. Just point me to the place where to put it. I've got comments on the extension bit. And the comment was actually, do we really need two?
Before you proceed, Noah.
Yeah.
So on the first one, do you want to add a pointer to the, I think it's right there, thoughts on positioning, right?
Yeah.
Or this is thoughts on encapsulation. Oh, can we add that pointer to the?
It's number 4 in that list.
Yeah, it's not here, right?
Yeah,
No, it's number 4.
Okay.
Yeah. So
right.
I tried to get a little more organization. So everything that's related to MIAD, I put in a subsection of MIAD. And but if you go back to that previous page, what's in 4 there are bits of it that should go into data after BOS because that relates to the part we were just discussing relates to the post-stack data, and the other parts of it may belong in one. But right now, I left it as a separate, as a separate entry.
What you're saying is you would actually make it a subsection of number 3.
I would take the last part and make it a subsection of 3, yeah.
Oh, okay. We can discuss where we actually cut and break things and where we put it.
Okay. Thank you.
So the next thing was that I got comments on the extension bit. And the thing I did was actually to take the entire 32 by bits minus the S bit and make it a flag field. I got 2 comments on that. One was that, okay, now we should do it the same way all the way. So we do the file style SPL, and then we do the same value of the label again, and then we have the same type of flag field as we had before, where the extension bit is present in both. And then I got another one that I don't really got my head around, but that was actually taking the label value, all 20 bits, and makes flags of them. There should be an X at the end. Yeah, that one. There should be an X at the end of that, I think. I don't have a preference really here, but
Oh, I have a clear preference. I mean, the first one is the one that I had proposed in the FAI document. The second one, I don't know what value you would put in the label field, the value field. You're wasting 20 bits if you don't have anything there. And the third one, you're wasting 11 bits. So the first one is the only one that says, let me use all the bits, which for the FAI style SPL, you need the SPL. So the first one, you're burning 20 bits just to say this is an FAI style SPL. But subsequent bits, because the X bit is 1, saying there's more, the next 32 bits, you should use all 31 of it. There's no reason to use less than that.
So you're saying do it as I did it in my text.
Yeah, and that's how it's in the draft.
Yeah, I have a question. Will this special label be the last label in the stack? Will we enforce that or not?
Probably not. It could be anywhere in the stack. It cannot be the top label, but otherwise it's anywhere in the stack.
So I think Hayu's question is rather, if you look at where I say I suggested this, the S bit in this second row, can you find that, Tarek?
Yeah, I can see it. Yeah.
Yeah, that could be a 0.
That could be 0.
Yeah.
Yeah, I mean, if this label, special label, or this flags always be the end of the bottom of stack, then we don't even need the extension bit. So the bottom of stack bit is enough to indicate that, right?
No. The extension bit does not indicate bottom of stack. It indicates
yeah, I mean,
that you have more flags
for example, if we have two such labels, like in the first case, then only the last one has a S bit set 1. So that's enough to indicate, okay, this is a real bottom of the stack.
Yeah,
right?
But it doesn't have to be 1. As Loa just pointed out, it can be 0 because there are more labels after this.
Yeah, I mean, if there's, but I just say that the assumption is, okay, we will keep all this always at the bottom of stack, no matter how many words or flags we have. If we have that requirement, then we don't need the extension bits. That's my point.
So I don't agree. First of all, this
Wait
can
a
be
minute.
anywhere.
Wait a minute. I want to clarify. If I think Tayu is saying if the bottom of stack bit is set, then the extension bit is 0.
No, he's saying that we don't need an extension bit if we assume that the FAI style label is the last label in the stack.
Yeah, that's what I understood. Right.
And I don't agree that it's the last label in the stack. I think the FAI label can be, can be not in the, near the top of the stack, can be at the top of the stack, but can be near the top of the stack. And then you can have 2 or 3 extensions in the way that you have it with the XBit. And then once that extension is over, there could be more labels. There could be, further labels. And then maybe 10 labels after that, you have the end of stack. So the positioning of the FAI label, the only requirement is it must not be at the top of stack. Everything else is game. So it could be the last label, it could be, in the middle of the stack, it could be near the top of the stack.
I agree on that.
I have a question, if you don't mind, to Loha. You have proposed a TLV, sub-TLV for each flag. Is that correct here? You're saying that
I
flag
think
number 7, is that what you're proposing? Like every flag will have a associated sub-TLV?
that's what I did. I know that there are many ways of doing it, but that's what the way. Yeah.
My question is not about the sub-TLV. It's about, if you have multiple FAIs in the stack, is that something you thought of? Actually, another way to ask the question is there only one ancillary data parent TLV? What do you call it? This one. Can there be multiple?
Yeah, that's what I thought, but I might be wrong, and that might be an interesting problem to solve. But this paper assumes that there are one extendable field for flags. There is one auxiliary data TLV, and then it's populated by sub-TLVs. That is actually every flag that indicates that there is data after the stack.
Okay, it's a
If
starting
you
point.
change that, we get into an interesting problem, but it's solvable.
Yeah. Okay, I just wanted to understand 7 means what 7? Which flag 7?
Which 7? It's you go back to the registry.
No. I mean, which 7 from which FAI? So if there are multiple FAIs, there will be multiple 7s. I mean, look at this example.
Wait, go back up to the registry I show you.
Yeah, not the registry. If you have multiple FAIs, you have multiple, presumably multiple positions of 7.
No, sorry, it's covered. You to the ready, stop. So you say that bit number 20 in red in flag in the first field is number 1, and then you go down to somewhere it starts with a 0. The first flag in the second field is number 13, and that's how you do it. If you want to separate the flag field, then you
No, I think Tariq is referring to a different problem. If I have two FAI style labels independent in the stack, so I have an FAI style label, maybe it has an extension, it has a second word, and then it has no more extension, so that one is done. 3 labels later, there's another FAI label, and it has an extension, and there's a second word, and then that has the extension with 0. So now 2 FAI labels.
But the registers controls which labels is which.
So if you have the, let's
No,
say,
but I have
label,
2 copies.
I understand.
Yeah.
But if you have let's say flag number 5 set in the first, you can't
Yeah.
have it set in the second
Why not?
because it's kind of competing.
So that's the point that Tarek is raising. One of the issues that we've wrestled with is, for example, forget FAI and everything. When we talk about ELI, entropy label, we said that in a very deep level with lots of labels, we could repeat the entropy label multiple times. And the reason to do that is, the way I look at SR in many cases, you push a big label stack at the beginning, and then you pop, and then when you pop, you might say, oh, here's my ELI. I'm going to throw it away because there's another one later with the same data. And then I pop, and then I get to the second one, drop it, and pop it, and remove it, and do that. The reason is that, if you say that this is going to be near the top of stack, when you get there, you have to pop it and then you lose it, unless you do a funky pop operation, which we can come to later. The alternative is you put it near the bottom of the stack, when then nobody can see it until you come to near the end of the LSP. So that's why we said we'll repeat it. So if you do the same thing and we repeat the FAI, if you take that approach with FAI, you will have repeated label 5 or label 7.
So might have been wrong. I think you can have it set, but it must be identical to what was in the first.
So that, I think, yeah.
If you make it identical, then I mean, yeah, that's one way to answer it, Loa. But I think we talked about FAI applicable to certain segments. So certain actions applicable to certain segments of a path, and this way we can have FAIs different. So flags for the first FAI are different from flags from the second FAI. Not identical.
You have flag number 9 set, and you have a definition for flag number 9 that is in the specification and actually tells you exactly what to do. And then you set flag number 9 in the second PHY, and you expect a different behavior. Where does that?
No, let me explain what I was trying to say is, let's say you have a path made of 2 segments. And in the first segment, you want to invoke action flag 7. And this, so you have an FAI for the first segment with the 7 flag set. And in the second segment, you don't want to invoke action flag 7, so you reset it. So you have another FAI with a flag 7 not set. Probably there are other flags set.
Yeah, but that is possible.
Yeah. So then you have a node that will process the first FAI that it sees, and it sees maybe flag set 7, and it goes to the end and processes that 7. Is that what happens?
I guess I haven't thought about it. It didn't occur to me that it was possible. But you can flip the flag, I think, between 2 different flag
they don't
fields.
have to be identical. That's the thing. They don't have to be identical.
Depending on what you mean. The specification is identical, isn't it?
No, I mean these flags here. If you repeat FAI and not back to back.
Actually, those 2 down there, go to the top one, because that one was the big. No. Up one 5 style. No. Down.
Down. Okay.
That one. That is on the top now.
Yeah. So Tarek, just to put you in the picture, these are 3 ways of encoding extension labels. So don't think of this middle one as 2 separate FAI labels. Ignore the middle one, ignore the bottom one, look at the top one, which has FAI style label, and the X bit should be a 1, and then you have the extension bits in the second row.
Okay. Yeah, that I understand. This is what you're proposing. Right.
Yeah. Okay.
Okay.
And then I say, well, I think you can allow repeating that same flag field again, but having at least one of the flags set in the first and not set in the other, because they actually apply. They are valid for different parts of the LSP, different segments. But I haven't thought about it, so I can't say that I actually want to do that. But it would be possible, I think.
So basically, you can repeat an FAI with associated stuff for two purposes. You can repeat the FAI because as you pop the label stack, you might reach an FAI and you have to throw it away, but you know that there's another one later. But you can also repeat an FAI for a different segment. And that second FAI could have very different settings and very different data. So for example, if the FAI that we're processing right now is in a domain that has network slicing, it might contain a slice ID. But when you finish that domain and you go to the next domain, you might not be doing network slicing, and the FAI has very different information at that point.
I think that's possible, but I haven't thought about it. I would like to think about it a little bit more before I say I agree to it.
Okay, sure. I will try to write this up for the next meeting.
Yeah, I have one question. If we have multiple FAI labels in the label step, does it mean we also need multiple like the sub-TLVs for the same flag in the post-bottom stack data?
That's one of the things I was thinking about. I don't know just now. I need to think about it, how it would work. But it's not entirely straightforward, but I think it's solvable.
Yeah.
It's a good. We need to solve it.
Actually, we have proposed a way to solve this problem. If we have a multiple sections or segments, we can basically partition the label stack into multiple sections, and each section has it's just a one FAI label for it, and followed by the the data after the bottom stack. Then after that, you can follow another section of MPLS labels. So, but
I agree that
if you just
if you split the stack into several stacks, each related to a segment of the LSP, then you can repeat the flags whichever way you want.
Yeah.
Because they are in different stacks.
Right.
I haven't addressed that problem at all here, and I think it needs more discussion.
So I can offer up a proposal for next time. I don't know if we can do it in the next meeting because the agenda is pretty full, but either the next meeting.
It's probably fuller than when we can actually swallow as it is now, because we need to sort it out. I need to talk to Kireti and Nick and Stuart and Andy to see how we do it. And Ballas and Lou.
Yeah.
Okay, you had a proposal.
Are you talking about to me?
Yeah?
No, I said I will put together a proposal for next time.
Okay, thanks. That's fine.
Yeah.
So now we go on to terminology and abbreviations. So can you go down so you get the terminology on the top of the page?
terminology heading on top of the page. There, okay, that's fine. This started with a text that Kireti put into the MIAD page, I think. And it has 4 bullets, and I'm kind of not agreeing to exactly what he put there. I think that we need, first of all, we need an acronym for no data, and I suggested one. And then I think that bullet number 4 is not a separate bullet. It's kind of what should I call it? Envelope or something, that where all the data that goes after the bottom of stack bit are part of the payload. So that's why I think
it depends how you define payload, because one definition of payload is the original customer packet before the encapsulations.
Then I oppose, if we do that definition, I oppose to within, then I say followed by number, then you are in my alternative new. And
yeah,
it's not within the payload, it's followed by the payload. It's missing a by.
yeah. So I mean, this original text, the old, was taken from your positioning statement, and in the positioning statement, we talked about all of these, and then within the payload, and I think the term was from there, but essentially, the end after the bottom of stack is a set of data that we still have to figure out what the formatting of that is. But that's some data that has to describe how long it is in some way. And then when that data is over, typically you expect the customer packet to finally start. But you might still have data that you put in the customer packet that you want to change for whatever reason, which we said we won't consider here. I might have misunderstood you, but that's what I was trying to capture.
I think we are not clear where we draw the border between post-stack data and the payload. And if we look at alternative new, number 1, 2, 3 are the post-stack data. Number 4 is the traditional payload. If it has data in it, yeah, fine. Then we need to have a way of handling that. But I take it that you actually more.
I mean, at the end of the day, I'm only concerned with the first 3. But for completeness, I thought I would add, because in your positioning thing, you had a 4th option. I thought I would leave it there.
Okay. So then if we want to do that, then I suggest we go with the alternative new.
Okay, that works for me. Yeah,
should be followed by, and
yeah.
I added the no data acronym also, abbreviation also.
Sure, yeah.
Yeah. Okay, fine. Be done. Then we can go down. I think, and this is one I'm not very sure about. So if we have flags for end-to-end and
hop by hop, and we have each flag indicating something on the on the data, then if we have more than 3 flags used, or I have 3 or more, then some of them could be end-to-end, some of them could be hop by hop, and 2 flags can never cover that fully. And when we discussed this last time, then Stuart said, okay, if that's the case, then the implementation has to go down and look what actually is the case. Can't conclude from the bits. And the table I have actually shows that.
So take me through this table again.
What? Take me through the table?
Yeah, I'm trying to.
I think there is something wrong in the table.
Oh, okay.
Tarek, can you swap on the HBH, the last row in the table? The 0 should be in the. No, now it disappeared.
No, he's editing
You
it.
need to go and do the. Okay. You go and do the edit. So in the HBH row, it should say 01.
I mean, so you have 2 flags,
Swap.
flag 1 and flag 2.
Yeah.
One of them is both are hop by hop.
Yeah.
Okay.
So you have a 0 and the end-to-end
Okay.
column. Yeah,
The
like
hop by
that.
hop flag is on.
Yeah.
Okay, for all the flags. So this E and H is applicable to all flags?
Yeah, that's the way it was done in the paper text I read.
Okay. I'm just trying to understand. So you have these 2 flags and they're applicable to all actions.
So the way that originally the E and H flag was intended is that the E flag says there is some data that is in the post data ancillary data, post stack ancillary data. And so if you're an intermediate router, they may not be of interest to you. And the H flag says that there's some data in the post stack ancillary data, which is interesting for every hop. So if you can, please go take a look. It wasn't to apply to any particular flag per se. It was really to say, generically, it's an indication to the router processing this. When I'm processing the FAI, if I see the bit E is set, then, and if the bit H is set, then I should do my best to go and look at the post stack data to see what's going on. If the bit H is not set, and if the bit E is set and I'm an end node, then I should go look. And if the bit E is not set, there's no interesting post stack data. So it's not on a per flag basis.
If that's a purpose, then I think a single bit is enough. The 2 bits are redundant. Because
I disagree, but okay.
If you know there are headers, let me finish. If you know there are actual headers after the bottom stack, then you only need to know if they are hop by hop on, and to if there's any headers are hop by hop, right? That's enough. Because if there's no, you just have single bit to indicate. If there's no hop by hop headers, then if there's a node end nodes, you will not need to look at them. So a single bit is enough.
Okay, so that's a good observation, but the high order bit is that these flags, or the E and H bit, or maybe just the H bit, to how use point, are only are a generic thing for the label stack. It's not specific for any flag. So if I'm processing the data, processing the label stack, and I come across an FAI style label, and I see one of the extension bits is the E bit is, the H bit is set to 0, I say, okay, there's no interesting data for in the post stack. If the H bit is 1, then I say, okay, there is interesting data, and I need to go look at it. And if I'm an end node to how use point, I'm going to go and look at it anyway. But if you need to actually signal it, we could have an E bit. But if you don't need it, you don't need it. But the high order bit is that these are generic for the entire label stack, not specific for any label, for any particular flag. So it's not like, oh, here's a flag that says that there is IOM data post label stack. And oh, by the way, it's hop by hop or it's end to end. There is something. If you have the cycles to go look in post stack data, then go parse it and find what you need.
So
that's yeah.
You're actually saying that in the table I have, and I think I'm starting to agree with you, you can remove the E column.
Yes, but the table you have, I guess I'm not completely sure.
Okay, so let me go.
Are you talking about the registry? Yeah.
No, I'm talking about
the
so
table here. Yeah.
You have in the received flag field in the file, you have 2 flags set, and you know that one of them is in the first case. In the first case, both of them are end-to-end. So I set the end-to-end bit, and the 0 bit in the H says that, okay, both are end-to-end, and a transit node can skip.
So these flags, they are flags in the FAI style extension bits. Flag 1 and flag 2.
Yeah, they are, yes.
So I think that's where I'm having a difficult time. So if you go back to the registry, just to take an
confused a little bit.
Yeah,
you had a flag and then position, and then you had
go to the top. So you see the top.
Top where?
Top
the
of the
registry.
Yeah.
The flag registry.
Yeah. No, that was right. You were at the right place.
Yeah, there's a lag. I think there's a lag.
Oh, okay.
You see flag registry?
Yeah.
Yes. Yeah.
Okay. Yeah, I was saying that you had name, maybe it was just a name, I don't know, but you had end to end and hop by hop here. What does that mean?
Where?
Name, under name column.
Look on the right.
Oh, I'm on the right hand side.
So okay, so that's a thing that was not updated. It should actually say E and H.
Okay.
Under name?
Yeah, it's the end-to-end bit.
Yeah.
And the hop by hop bit.
But these, okay, I'm confused. Is it per flag?
No, it's actually flag.
No. It's a flag of its own. Okay, so that's in line with what I'm saying. But I guess in the example below that we were just now editing, you had flag 1, flag 2, E, and H. And it looked like you're trying to say flag 1 is end-to-end and flag 2, but flags don't have end-to-end or H. What is the difference?
What I'm saying is that the post stack.
Oh, I get you now. I think I get you now.
Yeah.
So
the post stack data that the flag points to is significant end to end if the E bit is set, and it's significant hop by hop if the H bit is set.
Is this valid? I removed it, but is this valid? The H bit is reset, but you have hop by hop flag 2. Is this valid? I mean, assuming I don't have an E flag, I'll remove it just for simplicity.
Let's see.
Is this valid in your configuration? You have flag 1 is end to end, flag 2 is hop by hop, but I have the H0. So that means the transit node will look at the H bit, it will see 0, it will not process flag 2.
I'm starting to think that you might be right. I'm kind of. So that's the same thing as I said before. You can actually remove the E column. It would work.
Sure, but then, yeah, I think it's a blanket statement to all flags that once this is 0, I will not process anything as a transit
Unless
node.
I'm the end node.
Yeah, if I'm a transit node, I will not process anything.
Yeah, that's true.
Yeah, so then this becomes irrelevant, right? Flag 1, that doesn't have hop by hop and end. It's just one bit, right?
What did you do now? Now I kind of lost you again. I thought you said something that was right.
I think there's only flag.
You have. But wait a minute. The table, as described, says it has 2 flags.
Sure. F1
and
and
there
F2.
are a number of cases where in the first row the flags both have have data that is significant only to the end nodes.
Yeah, that's what I mean. You have two cases. One of them is H bit is 1, and one of them is H bit is 0. If H bit is 0, then these 2 flags will be processed at the end node, at the egress.
So I have a question. Can you give me an example of flag 1 or flag 2? I mean, what are these flags?
Yeah, that's lower. Okay.
And maybe if you go back to the registry, you can pick an example from there.
Okay.
So we know the node data is the NFFR.
Yeah.
Yeah. The in-stack data, I'm not sure how to distinguish between in-stack and after the stack, but there must be some criteria, and you should work on that. Right?
Yeah, no, it's described in the FAI document, but we can talk about it. But if you look at AD1, AD1 appears to be post-stack data.
Yep.
Right? So one of the things is we, at least the current FAI document, and we can change this, but the current FAI document says, I'm not going to say anything about post-stack data except whether it is of interest on a hop-by-hop basis or an end-to-end basis. So in fact, there would not be an AD1 flag 7. What they would instead be is an indicator saying there is hop-by-hop data, go look. And when you go look, when you parse it, the post-stack data is self-describing in whatever fashion we want to do it. And so there you'll find that, oh, there's some IOM data, or oh, there's some some auxiliary header, auxiliary channel. Whatever that is, you have to parse the the post-stack data to find out. The flags in the FAI will not tell you what is outside the data, outside the after the bottom stack. They'll only tell you go look because it's interesting hop by hop, or go look because it's interesting end to end, or there's nothing there. That was the original idea. Because then otherwise you have redundant data. You have flag 7 that says, let's say flag 7 is IOM and it happens to be carried after end of stack. Then you have a bit saying flag 7 is set, so there's IOM data, and it's interesting on a hop by hop basis. You go to the post stack data and you have to parse it anyway and say, oh yeah, there is IOM data. And so what was the point of actually signaling that up there?
I lost this
You're saying
somewhere.
that we only need one flag, Kiriti, to say go to the.
I had two, but let's go with how you suggestion. We have one flag. Essentially, when I'm parsing the FI style label and I'm looking at the flag, there'll be a flag that says, I've got a no FFRR, or there'll be a flag that says, there'll be flags that are related to in-stack data.
Yes.
I have an entropy label. I have a GIS, slice identifier. I have whatever else, right? And then there'll be just two flags for, or maybe even just one flag for post-stack data. Yes, there is interesting post-stack data for by hop basis, or yes, there is interesting post-stack data for end-to-end basis, but not any more details. If you see the hop by hop beta set and you're a transit router, go parse, go to the bottom of stack, parse the bottom of stack, find the data that's relevant. So you don't have to signal it in both places. Now, there may be a value to signaling it in both places, but in general, redundant data gets kind of a bit tricky. For example, if I have a flag in the FAI style label that says, I have hop by hop IOM data, and then I parse the post stack data and I don't find it, what am I supposed to do?
Yeah.
Right. Because
Okay. Yeah.
you have the same data in two places.
It's a good comment. So if you have in-stack data that has the same criteria, it can be either end-to-end or hop by hop. And you have post-stack data that can be the same. It could be end-to-end or hop by hop. So you need one flag for each.
So the in-stack data is assumed to be hop by hop. If it is not hop by hop, please don't put it in the label stack. Put it after the label stack.
Okay.
This is the principle of parsimony that I was trying to elucidate. If it's not important for every hop to see this, put it somewhere else. The label stack space is precious.
So let me put. So what? Okay. So if we have post-stack data of both kinds, we need to point out for each of the data. But how do you find them?
So you go to the bottom of stack, and you can do that in a couple of ways. You might have a pointer that says, here's where the bottom stack ends.
I'm there.
Yeah, okay.
So I use the flag number I have in the registry to find which flag it is. Right? And then I have a bit set to indicate whether it's end-to-end or hop by hop.
No, I missed that. So you have a flag number to find the end of stack?
No. I'm starting to parse the data after the
end of stack.
End of stack.
Okay.
And then somewhere you have, as we looked before, flag number 7.
Yeah.
and we know that so you put the number 7 in the bottom of stack.
If you organize the bottom of stack as TLVs, then you put the TLV corresponding to that. I'm trying to keep it open because people have different ideas, but let's just make it very simple. You say the bottom of stack data is organized as TLVs. So once you know that there's something interesting in the bottom of stack, you go through the labels until you find the S-bit 1. Then you say, okay, now the post stack data starts. I know how to parse this because they're TLVs. There might be a super header like you mentioned, and then I actually header with a TLV that says IOM data, yay. Then another, and then it says length is 3, and then you skip over 3 things, and then you say, oh, the next whatever it is. So you parse the end of stack, the post end of stack data must be self-describing. So you don't need to have anything in the FAI label saying, oh yeah, by the way, if you do get there, you'll find IOM data. You will parse it and you'll find it.
So what did you get in the FIA label?
You got whether you should look or not, whether there's, for example, if the only thing is end-to-end, and I'm a hop-by-hop guy, don't bother going to post-stack data because there's nothing interesting for you.
We agree on that.
Okay.
But if I look at your, you have all the flags. Can you bring up Kireti's document?
Which document?
FAI.
Yeah.
MLSP for FAI.
01, right? Yeah.
Yeah. And then you go to the figure where you have the go down. Stop. No.
No, where the bits are laid out.
Yeah.
Oh, well, you can, yeah, that one works. Yeah.
Yeah.
So
if I
I'm
hear
using, yeah, go ahead.
If I hear you correctly, you're saying I only need one bit here to tell me whether I should go look after the bottom of stack. And the other flags here are
so maybe that's not the best picture. Can you go to the one that shows the flag definitions further up, I think, the other way.
I'm going upwards.
Yeah. Okay, here.
Yeah, right?
Yeah, right. So the capital H flag is the extension, what you use X, it's the extension header.
Yeah.
The A flag is that there is label stack data. Okay, that's an optimization. Ignore that. The N flag is the no FFRR flag. The E and G flags are entropy label and GIS, the stack, the slice identifier. And the F flag is essentially for the flow ID, which was a document by someone that he wanted a flow ID in the label stack. I'm not sure it should be in the label stack, but we can just decide that later. And then there's the H flag, which is the H flag as you're using it, which means there's hop by hop data for what I call here PLFAD is what we are now calling post stack data. So there's post-stack ancillary data, which is interesting on a hop-by-hop basis if h equals 1. And if h equals 0, there isn't anything. And so if you're a transit router and h equals 0, don't bother going to the bottom of stack. If you're a transit router and h equals 1, go and look. And of course, if you're an end-to-end router, you're going to go to the bottom of stack anyway. I mean, if you're an egress router.
I understand how that works for the H bit
Yeah.
for post-stack data. How
Yeah.
does it work for in-stack data?
Oh, in-stack data is implicitly hop by hop. So if you have any data, go ahead.
So don't you need an indicator that it's there?
Yeah. So so if you look at the EG bits, the E says there's an entropy label, and the G says there's a GIS. There's a, what do you call it, a slice identifier. So if E is 1, actually it's a 2-bit flag. So, but let's pretend that 2 single-bit flags. If E is 1, then there's in-stack data, which is a label, which is an entropy label. And if E is 0, there isn't one. And if G is 1, there is a slice identifier. And if G is 0, there isn't one.
Wait. Now I'm kind of trying to understand. So why is not the in-stack data self-descriptive also?
Well, first of all, we don't have a lot of space in the label stack to put a TLV and length and all those fields. So that's why we indicated with flags. So the E bit says there's an entropy label. If there's 0, there isn't one. If there's 1, there's an entropy label. The G bit says, and I'm simplifying this, actually is a little more complicated. There's an algorithm further down that says exactly how to parse it. But if we actually made it self-describing, then we'd try to put a TLV structure or something, and we don't have the bits for it. We want to be very, very bit efficient in the in-stack data.
I can accept that. So you have 2 flags, and you only allow 2 different in-stack data.
Yeah, for now, yeah. Well, there's a third one, which is no data, which is the no further parser out. So it is an in-stack, I mean, it is an indicator, but it has no data.
Kind of. But if both E and G is 0, isn't that the same?
So E and G is actually a 2-bit field because we want to capture more than there is. There's entropy. So it actually is a 2-bit field. And so the 0 value means there isn't anything. 1 means there's a 31-bit guess. 10 means there's a 31-bit entropy label. And 11 means that they're both sharing 31 bits. I mean, that's some detail, but the point is that the in-stack data, the description is in that 2-bit value. What is the format and everything. We don't want to have a TLV structure for this.
Well, time check. I think we went over.
Okay, yeah, way over time.
I will stop recording if you're okay.
Yeah, that's okay. Yeah.